All right, let's jump right in. Welcome to this explainer. Today we are demystifying the fascinating and, honestly, high-stakes world of manufacturing inventory. You probably don't think about factory supply chains every day, but the complex math happening behind the scenes, it literally dictates whether our modern world runs smoothly or just grinds to a complete halt. So, let's get into it.
To ground this in reality, think about the sheer, crushing disappointment of craving hot fried chicken from your local convenience store, only to walk in and find an empty display case. It's a universal feeling, right? Well, our source material points out that convenience store fried chicken is actually considered one of those critical items that should fundamentally never run out. Why? Because the level of customer disappointment when they hear, "Sorry, we're sold out," is massive. It's not just a missing snack, it's a broken promise. And for the store, it's a huge missed opportunity, because those items carry a really high profit margin.
And that brings us to the ultimate dilemma every business faces: missing out on high-profit sales versus the tragic waste of overproducing food that just doesn't sell. It's a total tightrope walk. If you stock too little, you frustrate your customers and bleed potential revenue. But if you overcompensate and make way too much, you're forced to throw it away. That means wasted resources, lost capital, and unnecessary disposal costs. Ideally, businesses want to keep inventory as low as humanly possible to save cash, while simultaneously guaranteeing they never, ever face a stockout. Sounds like an impossible paradox, doesn't it?
To solve this exact dilemma, the manufacturing industry relies on a crucial concept called safety stock. Basically, safety stock acts as a strategic buffer. It's that carefully calculated extra layer of inventory kept on hand specifically to absorb the shock of unpredictable fluctuations, whether that's a crazy spike in customer demand or sudden supply chain delays. Think of it like an insurance policy for your inventory. When everything goes perfectly to plan, your regular inventory handles the day-to-day. But when a sudden surge hits or a supplier is running late, your safety stock kicks in, ensuring the customer never even notices a hiccup.
Now, you might expect the calculation for this to be some convoluted mess of variables, but it actually builds upon a surprisingly simple mathematical formula requiring just 3 key elements. Finding your ideal safety stock really just comes down to understanding and combining these 3 pillars: demand fluctuation, lead time, and your safety factor. When you combine them correctly, you completely strip away the guesswork and replace it with hard, actionable data. It transforms a total guessing game of, "Geez, I hope we have enough," into a scientifically backed guarantee. Let's break down each of these 3 elements to see exactly how they work.
The first element is all about accounting for chaos. Look, demand is rarely a flat, predictable line. It spikes, it drops, it totally surprises you. If you sold 100 items last month and a whopping 1,000 this month, you have to calculate that variance using standard deviation. If your sales suddenly jump tenfold, an average inventory will leave you completely exposed. By using standard deviation, which is a statistical tool you can easily calculate in basic spreadsheet software, you can accurately measure the average variance of your demand. The larger the variation, the more safety stock you're going to need to protect yourself from those wild swings.
The second element is lead time. This is absolutely crucial, because the longer it takes to procure materials, the wider your window is for unexpected demand spikes. Lead time is simply the duration between the moment you place an order for materials and the exact moment those materials actually arrive on your factory floor. If it takes a long time to get your parts, you're effectively flying blind for a longer period. And as time stretches on, the potential for demand to diverge from your forecast grows significantly. So naturally, a longer lead time automatically demands a larger safety stock to cover that extended period of vulnerability.
Okay, this is where it gets really interesting. The third element is a specific statistical safety factor, and the industry standard actually guarantees an impressive 95% success rate against stockouts. Here's how it works. The safety factor is based on your acceptable stockout rate. If you wanted to meet demand perfectly, 100% of the time against infinite variations, you would mathematically need infinite inventory, which is obviously impossible. So businesses set a target. If you're okay meeting demand 9 out of 10 times, your statistical factor is 1.29. If you want a 99 out of 100 success rate, it bumps to 2.33. But the sweet spot for manufacturing, that 95% success rate, gives us this magic number, 1.65.
To see this all in action, let's put some real numbers to a hypothetical factory scenario. Imagine our facility has an average daily demand of 1,000 units of a product. We've calculated our standard deviation, that demand fluctuation we just talked about, to be 100 units. Our lead time to get new materials is a crisp 5 days. And because we want that ultra-reliable 95% success rate, we're locking in our safety factor at 1.65. With just these 4 clean numbers, we can completely remove the guesswork.
When we run the math, the result is exact. By multiplying our 100 units of standard deviation by the square root of our 5-day lead time and applying our 1.65 safety factor, we find out we need exactly 369 safety units. Let's just walk through that one more time. Standard deviation times the square root of the lead time times the safety factor. The math reveals a highly precise answer, 369. This isn't just some random buffer, it's a statistically sound safety net. It means that on top of what we expect to use normally, we must always keep 369 extra units sitting quietly in reserve to absorb any sudden shocks.
So, here is the real kicker. Whenever our total inventory dips to exactly 5,369 units, we have to immediately trigger a new order to avoid empty shelves. This is known as the reorder point. We calculate this by taking our average daily demand of 1,000 units, multiplying it by the 5 days it takes for a new shipment to arrive, which gives us 5,000 units of expected demand during the waiting period. Then we just tack on our freshly calculated safety stock of 369 units. The absolute second the warehouse scanner registers exactly 5,369 units left in the building, the system knows it's the precise mathematical moment to place the next order.
But wait, before you think you've totally mastered supply chain logistics, our source material delivers a massive reality check. That beautiful, clean formula we just walked through? Yeah, it works perfectly in an isolated theoretical environment. But the reality of an actual manufacturing floor, it's infinitely more complex than a textbook equation. The simple math assumes a level of stability that just doesn't exist when metal is actually being cut, machines are running, and hundreds of human beings are working together. The formula is a great foundational theory, but applying it to the real world requires an entirely different level of capability.
Because think about it, real manufacturing sites aren't just calculating the stock for one snack. They are juggling thousands of components, fluctuating factory capacities, and totally unpredictable global shocks. Imagine trying to run that safety stock calculation manually, but for a car engine that requires thousands of distinct, tiny parts. And imagine doing it while one of your machines goes down for maintenance, meaning your production capacity just suddenly changed. Add to that the unique characteristics of items. Maybe some materials expire rapidly or need special storage. Then throw in unpredictable external factors, like a massive storm delaying a shipping container. A textbook formula simply cannot scale to manage this staggering, multi-layered web of constraints.
So to manage this overwhelming chaos without causing massive delays, modern factories have to completely abandon manual calculations and implement specialized software known as production schedulers. This is where the industry shifts from manual guesswork to high-powered computing. A production scheduler is a sophisticated digital tool designed specifically to hold all of those thousands of variables, the parts, the machine capacities, the labor schedules, the safety stock limits, and its digital brain all at once. It does all the heavy lifting, constantly analyzing the real-time state of the factory floor to generate the most efficient possible plan for production. It goes way beyond human capacity.
Schedulers are absolutely the key to driving digital transformation, or DX. They significantly cut down lead times and drastically reduce inventory holding costs. By implementing this technology, a factory isn't just buying a new piece of software. They're fundamentally upgrading how they operate from the ground up. Because the scheduler can optimize the exact moment a machine should run or an order should be placed, it physically reduces the time it takes to produce goods. And by keeping inventory precisely where it needs to be, not too high, not too low, it absolutely slashes those massive costs associated with holding excess stock in warehouses.
By leveraging all this real-time data, these systems ensure that a factory's entire production process operates at maximum efficiency, no matter what crazy surprises the market throws at them. Say a supplier calls in suddenly and says a delivery of crucial screws is going to be 2 days late. A human planner might panic and spend hours trying to manually adjust the entire week's schedule. A digital production scheduler, on the other hand, instantly absorbs that real-time data point, recalculates the entire factory's workflow, and seamlessly shifts production to other viable products until the parts arrive. It literally keeps the factory humming without skipping a beat.
It really makes you wonder just how fragile our global supply chains are and how absolutely vital this software is to keeping the modern world running. We started out by talking about the math required to ensure you can always buy your favorite fried chicken snack. But as you've seen, scaling that math to a global industrial level requires immense computational power and strategic planning. The margin for error is razor thin. So I'll leave you with this thought. As our world becomes increasingly interconnected and totally unpredictable, those still relying on textbooks and spreadsheets are falling far behind. The future of making sure we never run out of anything lies entirely in the power of digital scheduling.